Hi guys, I hope you are all doing well. Let's see today's question. So today's question we have taken it up from the topic of parabola, and we are continuing off a series of questions on JEE Advanced. So today's question we have taken it up from the year 2014, and in the question we have been told that y square is equal to 8x is a parabola. Then we have been told delta 1 is the area of a triangle whose endpoints or the vertices are given p half comma 2, and the other two vertices we have been told they are endpoints of the latus rectum. And we have been also told that there is another triangle delta 2 which is having the vertices of the tangents drawn at p as well as endpoints of latus rectum. So we need to draw the tangents at these 3 points of the first triangle, and whatever may be the intersection points, those will become the vertices of the second triangle. And then we need to find the area of the second triangle. And in this question, we have been asked to find the ratio of area of first triangle to second. So that ratio is asked to us. And there are 4 options given to us. We need to find out which of the 4 is the correct option. So A is 1, B is 2, C is 3, D is 4. So these are the 4 options given to us. Let's figure out which of them is the correct one. Before understanding that, if I first compare the given parabola equation with the general equation, y square is equal to 4ax, I get 4a is equal to 8. A becomes 2. I get the value of a. Now I understand where my central point of the parabola will be on the x-axis. Now once I get a, I can just find the endpoints of my latus rectum. So if I try to figure out endpoints of my latus rectum, I know the parabola, that for a parabola latus rectum endpoints are given by a comma plus or minus 2. So you get this 2 comma plus or minus 4. So your endpoints of the latus rectum become 2 comma 4 and 2 comma minus 4. Now once you have all the 3 vertices, you can form the first triangle. Let's form that. So if I draw it here, so this is the y-axis, this is the x-axis. If I draw the parabola here, we have this parabola here, and this is 0, 2 comma 0, which is a. Now if I draw a latus rectum to show, this is latus rectum which we have. So this is our latus rectum. Now we know this point is 2 comma 4. This point is, which are the endpoints of the latus. Now if I draw one more point that is given to us, that is P half comma 2. If I draw that as well, so P half comma 2 will be somewhere here. So half comma 2 is somewhere here. If I join that also with triangle, I get the sides of the triangle 1. What is this? So you get this triangle form, and we have to find the area of the triangle which is given by delta 1 here. So if I draw that triangle 1's area of triangle 1 means you're finding the area of this P as well as endpoints of latus rectum. Let them be QR. So you are just finding the area of triangle B. And once you're finding area of triangle PQR, it is nothing but half base height. So if you see the base here, the base is nothing but the difference in the y coordinates of Q and R, that is 4 units above the x-axis and 4 units below the x-axis. So the total measure of the base of the triangle becomes 8 units. Height, if I want to figure it out, height is nothing but from the opposite vertex and from perpendicular. And when you drop a perpendicular, you get the height here. If you want to figure this height out, it's nothing but the difference in the x coordinates now, because this x coordinate is, this point is half and this x coordinate is 2. So the height becomes 2 minus half. So this gets cancelled and you get 4. And 2 minus half becomes 3 by 2. This gets cancelled out, you get this as 6. So you get the area of the first triangle, that is 6 square units. Now, if I am drawing tangents to all of these 3 points P, Q, and R, we'll get some lines. Once we get the equation of lines, we can just find the points of intersection of those lines. So let's try to find the equation of the tangents at these points of the parabola. So if I draw a random tangent from this point, let's say Q. If I have a tangent here, which touches this parabola at 1.4. Now let's figure out how to find the equation of tangents to the points at the parabola. Let's find the general equation. So if I have a parabola, let's say one parabola is there. This is y-axis, this is y-axis. And this is a parabola, let's say y squared dx. And if I have a one point, let's say x1 comma y1. Now we have been told that we need to find the equation of the tangents at this parabola. So if I want to figure out the equation of the tangent which is this point at the parabola, let's figure that out. We know the equation is y square equal to 4ax, and since this point lies on the parabola, so it will satisfy this equation of the parabola. You get that as y1 square is equal to 4ax. This is, let's say, one equation. Now, once I have the equation of parabola with me, y square equal to 4ax, if I solve this further, so if I differentiate it with respect to x to find the slope of the tangent here, so what I will get here is dy by dx. So y square's differentiation is 2y, so 2y dy by dx is equal to 4a into derivative of x, that is 1. So you get here as dy by dx is equal to 4a upon 2y, or you get that as 2a upon y. Now once you have this, dy by dx is nothing but the slope, and at this point x1 comma y1, if I try to find the slope, because I need to find the slope of this line, so m at point x1 comma y1, slope of this line becomes 2a upon y1. So we get the slope of this tangent. Now if I just use the idea, I know that equation of line or equation of tangent, which is a line which we want to find out, it's given by y minus y1 is equal to m x minus x1. So I have here y minus y1 is equal to m is given to me to a by y1 x minus x1. If I try to solve this further, I get this as y minus y1 again multiplied with y1 is equal to 2ax minus 2ax1. If I try to solve this, I get this as y into y1 minus y1 square 2ax minus 2ax1. Now we already know y1 square from 1 is 4ax1. So if you substitute that, you get that as y1 minus 4ax1 is equal to 2ax minus 2ax. If I bring this 4ax1 also on the other side, it becomes 4ax1 minus 2ax1 plus 2ax. So you get this as 4a by x1 minus 2ax1 is 2ax1 plus 2ax. So you get 2a common, x plus x1. So you get this equation of tangent to the points which are drawn on the parabola. So equation of tangent, I am getting it in the form of y into y1 is 2ax plus x1. So if I solve, or if I put or substitute my all the 3 points which I had P, Q and R that were the point P given and the endpoints of the lattice rectum, I'll get the equation of tangent to all the 3 points on the parabola. So let's find that out. So if I see at point P, we knew the coordinates were half comma 2. So x coordinate, if I substitute that as half, and the y1 coordinate which is there, I can substitute that as 2. So you get the equation of tangent drawn to point P on the parabola as 2 into y is equal to 2 into a. A we already know it is same for all the 3 points. So let's substitute a first also. A is 2. So if I substitute a directly here, my equation of tangent transforms to 2 into 2, that is 4, x plus x1. So you have this idea now that 2y is equal to 4, x plus half. If I try to solve this expression, y becomes 2 times x plus half, because I'm taking this 2 on the other side, so 2 gets cancelled with 4, 2 ones are 2 twos are. If I solve this further, I get y is 2x plus 2 into half, that is 1. So you get one equation of tangent at P. So this is one equation. Other equation, if I try to solve this again at point Q, we know the endpoints of lattice rectum were 2, 4 and 2 minus 4. So if I substitute those points also, so equation of tangent at point 2, 4, the equation becomes y into y1, so y into 4 is equal to 4 into x plus x1. So 4 into x plus x1, that is 2. So you get this also cancelled here, y becomes x plus 2. And further, if I find out the equation of tangent at point 2 comma minus 4 also, get y into minus 4 is equal to 4 into x plus 2 again. So you get this and this also cancelled. So you get the equation minus y is also x plus 2. So now if you try to solve this 3 equation of lines, now once you have this 3 equation of lines that are nothing but the tangents, I'll get the points of intersection which will become the vertices of the second triangle, for which we have to find the area. So if I solve first and if I solve second and third first, so I can just find the points of intersection by solving the 2 linear equations simultaneously. If I add them, I get this as 0 is equal to 2x plus 4. 2x is minus 4. Get x as minus 2. Once you get x, now if I want to find y here, I can just substitute y as here in any one of these equations, because I have solved these 2 equations first, 2 and 3. So we have solved equation 2 and 3. Get x as minus 2. If you put x as minus 2, you get y as. So that gives you the first vertex of the second triangle. Let's say my second triangle is ABC. So I get the first vertex, that is minus 2 comma 0, which is A. Now let's figure out B and C as well. So if I solve equation 1 and 3, equation 1 was y is 2x plus 1. If I'm solving equation 1 and 3, we know y is 2x plus 1. And third equation, we know it is minus y is x plus 2. Again, if I add them, this gets cancelled. You get 3x plus 3 is equal to 0. X becomes minus 1. You put x as minus 1 in any of the 2 equations above. So if I put x as minus 1 in the first equation, you get y is minus 2, because 2 into minus 1 is minus 2, minus 2 is 1. So you get the second vertex also of the triangle, let's say B, that is minus 1 comma. Now let's solve first and second equation also. So we get the third vertex also of the triangle. So you have y is 2x plus 1. You have y as x plus 2. Now, instead of adding, if I subtract, because y should get cancelled out, get x minus 1 is equal to 0, so x becomes 1. And if I substitute x as 1 in the first equation, y becomes 2 plus 1. That is. So you get the third vertex C, that is equal to 1 comma 3. So now once we get all the three vertices, we can just find the area of the second triangle which is asked to us. So I get the three vertices by points of intersection. A is minus 2, 0. B is minus 1, minus 1. C is 1 and 3. So once I get this, I can just find the area of the triangle second, which is formed by the tangents drawn to the 3 points P, Q, and R. So I can just use the idea of the collinearity, that is half of the determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. So you get this as half of determinant of minus 2, 0, 1, minus 1, minus 1, 1. So if you solve this determinant, you get half of minus 2. This becomes minus 1, minus 3, so minus 4, minus 0, because 0 into anything is always 0. We do not need to go and solve that further. Plus 1 into minus 3 minus minus 1, so minus 3 and plus 1 minus 2. You get that as half 8 minus 2, that is half of 6, and you get the area of the triangle 2 as 3. So you get that as 3 square units. Now once we got both the areas of the triangles, we just need to figure out the ratio. And if I try to figure out the ratio of the two areas of the triangles, the first triangle area was 6 and the second triangle's area comes out to become 3. You take the ratio, you get that as 2. So if you see the correct answer that matches here with the question is B. So B is the correct answer of the question. I hope you have understood how to solve this type of questions on parabola. So we first figured out the value of A. We got our endpoints of the latus rectum as A comma plus or minus 2A. Once we got that, with P, we formed a triangle whose area was easier to find out by just using half into base into height. So you get that as 6 square units. Then we figured out the equation of tangents at the parabola, that is given by this idea. I into y1 is equal to 2a x plus x1. So with the help of that, we figured out the tangents drawn to all the 3 points P, Q, and R by just substituting those points as x1 and y1. We got 3 equations of line that were nothing but my equations of tangents. Solving that by using intersection points. So solving the two equations simultaneously, we got 3 points A, B, and C that helped us to form second triangle whose area was easier to figure out by using half into determinant of this entire thing. That gave us the area as 3 square units. Once we got the two areas of the triangles, we just took out the ratio and got that as 2. So this is how you solve this type of questions. Okay, I'll see you again tomorrow with some other question from some other topic. We'll continue of a series of questions on JEE Advanced. So please do like, share, and subscribe to my channel. Also, do share these videos with your friends who are also involved in the preparation of JEE Advanced, so they can also take the benefit from this. Thank you.